From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Don Felker.
And I'm Kaushik Gopal.
Welcome to the show. This episode of Fragmented is brought to you by Bitrise.io. Bitrise is a mobile continuous integration and delivery platform for your whole team with dozens of integration with your favorite services. They've got automatic platform and configuration detection, and you can build, test, and deploy in minutes. They also have an open source library of 170 plus integrations that requires absolutely no scripting. You can run the same exact configuration actually locally with the open source command line interface by downloading the bitrise.yml file as well. Furthermore, they have virtual device testing for Android folks. So they have full integration testing with Firebase Test Lab. You can run your emulators quickly and reliably. And you can check that out at the Bitrise blog. Lastly, but certainly not least, is they are hiring tooling and DevOps engineers on site in Budapest, Hungary. So if you're interested, also check out bitrise.io/careers. So again, if you're looking for a continuous integration platform, be sure to check out bitrise.io. Kaushik, how you doing, man?
I am doing good. New day, another day of working with Kotlin and Android and all good things.
Did you ever upgrade to Dagger 2, or are you still on Dagger 1?
Because Dagger 1 has been pretty involved and we've been using Dagger 1 for quite some time, we're in the process of migration. So, and the way we chose to go about this, at least now, is essentially have both Dagger 2 and Dagger 1 in the interim, and essentially try to move everything from Dagger 1 to Dagger 2, and hopefully one day we'll be completely in Dagger 2. So yeah, it's been a little painful, but I think, I'm just waiting for the day where we're all just in Dagger 2 and we don't have both Dagger 1 and Dagger 2. And I got to ask you this as well. Do you find Dagger to be a little frustrating these days?
Yeah, I have found it. You know, when Dagger 1 came out, it was just simpler, it felt. And then Dagger 2, I felt like everything got really complicated. And then it got even worse right around when the Android extensions came out. There was just a lot of kind of looking at the screen, throwing my hands in the air, what? Why do I need to do this? And I know that you and I have shared some of these conversations before of why or what we're going through in relation to Dagger. Could be build times, could be annotation processing, could be a number of things. And we've just talked about it and said, hey, we got to find someone that has been down this road before, has felt the same pain, to talk to them to see what they've thought. And we actually found someone recently. And so I think without further ado, let's welcome Danny Preussler to the show. Welcome to the show, Danny.
Welcome, Danny. Yeah.
Thank you.
It's funny you brought up Dagger Android extensions down. I haven't even used it. I was I'm trying to get the basics first. Let me just get the basics. I don't even want to bother with the Dagger Android extensions part. So
yeah, it's one of those things, if you haven't really used them, then you really don't know why you need them. And then you kind of get into it and people talk, well, this is why you need it. This is why you have to use it, because this is the proper way to do it. And this is what Google says. And then you kind of run into all these weird edge cases. And I mean, I'm going to loop back actually to Danny's, the reason why we got Danny on the show here is he had tweeted something just recently about a couple of talks he had done, and one of them was at App Builders 2018, and I think the talk was titled "To Inject or Not Inject: Dependency Injection in a Kotlin World." And the thing that really struck me that drew me in, and I sent this link to you, Kaushik, was the first slide image was this guy, I don't know if it's paint or whatever's all over his face, and it's kind of a dark image, and it looks like he's got a needle in his ear or in his head, and it's looks like he's being injected with Kotlin or something like that. And it just really kind of tripped me out when I saw it. And that kind of hooked me into the slides, and I started going through it, and I said, oh my goodness, this, what Danny's talking about is exactly what Kaushik and I have kind of been discussing on the side. So it's very interesting. So I was wondering, Danny, what was the reason that you had decided to talk about this topic, or to inject or not inject? Actually, let me rewind here a little bit because I haven't even introduced you properly. For folks that aren't familiar with who you are, maybe where you've worked, kind of where you work now, would you mind giving a little bit of background information about yourself?
Sure. Thanks for having me. I'm Danny. I'm located in Berlin, Germany. I worked with Android for quite some time. I worked for eBay, for Groupon, Viacom, so a few American companies. And recently I joined a small startup here in Berlin called Sport Total. And I know exactly what you're talking about between Dagger 1 and Dagger 2 and all of this. I've been there, done that, and happy to hear that I'm not the only person. And that is basically also why I started this and other talks about dependency injection.
It's funny. It's almost like a rite of passage these days for folks who've been working on Android for some time. Like invariably, Dagger seems to be like the dependency injection choice. Mm-hmm. And now that everyone's like moved, like Dagger 2 is sort of like the next wave. It's been, and also the timing with Kotlin has made it very interesting because people are like, well, do we need Dagger anymore?
Yeah, I'm totally with Don. Dagger 1 was far more simpler, and then Dagger 2 came. And now Dagger 2 is like the one thing, but there's one thing no one thought about it. Kotlin happened, right? I'm doing Kotlin for 2 years now, and this brings back to the image that you saw, like that guy that got injected with Kotlin, right? I think Kotlin changes a bit the way we program, the more we're using it. And I think it also made a lot of people think about how to use dependency injection.
Yeah.
And if this is still the way to go.
So was that the impetus for you giving this talk? Did you also face similar issues where you were like, oh my God, this is like, there should be an easier way? Or also given what the language Kotlin allows us, is there a way where we can rethink this same idea of dependency injection, but probably come up with something that's a tad bit easier to sort of like deal with? Was that the idea for coming up with this talk? Like what prompted you to come up with this talk?
I think it's like two things. So I started in this new company and we had a greenfield application, and I thought, okay, that's a pure Kotlin project. What do I use for dependency injection? And with the experience we had at Viacom with Dagger 2, I know what not to use. So,
ouch, yeah.
So I started with using one of the frameworks called Toothpick, and then I realized it's not nice for Kotlin, so I added some extensions, and we kept going from there. And at the same time, there was a time a few months ago where basically every week a new blog post came. Hey, this is how to do dependency injection and Kotlin, and here's this new framework, and here's this new framework, and like something was definitely going on. And I thought, okay, let's look into this and make a talk out of this.
No, I mean, that's pretty smart because that is true, right? Like let alone just how to deal with the dependency injection Kotlin, I think almost semi-regularly, right? Like you just have to open up like the Android dev Reddit thread or like just see on Twitter, like almost semi-regularly you have people coming up with blog posts that say, hey, this is how you should be using Dagger, or this is how I use Dagger, right? And I guess at some point it makes sense, right? Because like this, it seems to be like this evergreen, complicated topic where people don't necessarily completely understand, right?
The thing that's interesting inside of your talk is that you really dive into the core of what the topic is about, dependency injection in a Kotlin world, and that's very interesting to me because we're at the forefront of technology. Like you said, we have Kotlin. You're perhaps maybe not using Dagger for whatever reason, but that kind of opens the door of like, all right, then what do we use? But I think before we can understand what we can use, we kind of almost need to understand like where we've came from. And you had some slides on your presentation that really visually walked users through or viewers through the history of dependency injection. I wonder if you could kind of walk us through some history of dependency injection for the listeners.
Sure, I can try that. So before I did Kotlin, I did Java for a long time. I think the first Java book I had was for Java 1.1, so that's like some time ago. And I remember like Java 2, the big thing.
Whoa, this is not Android 1.1, this is Java 1.1.
Wow,
dang,
old school.
Yeah. I've seen some of those. So I thought it's nice to go back. And especially the reason to do this was also, there are some discussions going on right now of those new things in Kotlin are really dependency injection. I think we can talk about this later, but this is a discussion that also happened in the past quite some time. So I thought, okay, let's go back in time and start at the beginning. And the beginning, I would say, is before Java. It's like using the new keyword to create something, right, in whatever language it is. And I always say, and not only me, like the new keyword that screams implementation detail, right? So a class should not create anything because there's probably something else this class should be. So that's why the whole discussion, like frameworks, like dependency injection ideas came from. So hide this new. And in the beginning, we didn't have any of those, right? So I started this timeline that you mentioned in like 1994 with like the design patterns book,
Wow.
like the Gang of Four.
Yeah, that's an old school one.
Because there were like some patterns in there that showed us how to create like how to hide the new, like the I don't know, the builder pattern, the factory pattern, stuff like this. And it had quite an influence. And like by the late 90s, like you had everything behind factories. I would say that's also from what I found so far. So it took some time until like something better came up. And I found out, and I didn't know it back then, or maybe I forgot, Java 1.3, so we're in the early 2000s now, there was something called a service loader built in. So you could specify in a manifest file an interface and implementation, and then at runtime ask, okay, give me an implementation of this. So this was pretty cool. I didn't know that was existing, but the service loader was built in Java 1.3 in the Java specification.
And I'm going to like just try to recap. So like I make sure I follow along. So you said, okay, we started off with like the new keyword, and the new keyword is like this. Everyone knows the new keyword, right? Basically, my understanding, like a very rudimentary understanding of dependency injection is like, oh, you don't want to use the new keyword. This needs to be injected, which is where the I comes from. This needs to be injected from outside. Okay, great. So instead of the new keyword, let's like think about different ways of going about this, right? You said the factory pattern. Yeah. And like, that makes sense. So like, the almost every book out there today has talked about like the factory pattern. Okay, cool. Now you're saying service locators was in the early 2000s. Like this is like a thing that existed like quite some time back.
Yeah, absolutely. And we are like in the times before dependency injection. I mean, you just said we want to inject this. I mean, this wasn't the thinking that we had back then. It was just, let's hide this new and let's split our code in like in two parts, right? One creates something somewhere and the other, this is where we use it. So there were different ideas, and like service locators, or how Java called it, service loaders by then, was one way to solve this. There is something, and this will create something for you, like a factory, right? In the end.
I love that you said that. So the objective is basically you don't want it to be created here. You just want to hide where it's created. So you want it to be created somewhere else. So you want it to be somebody else's problem.
Yeah, separation. Yeah.
Exactly. Separation of concerns. That's what you want to achieve in the end.
Perfect. Okay. That makes sense.
And at some point, like the first frameworks popped up. I mean, some you might call service locators nowadays. Some probably, from our point of view now, they were dependency injection frameworks. Mm-hmm. But this term wasn't found at the beginning. They were called inversion of control containers.
Mm-hmm. Yeah, I remember that.
So there were a few of them. Pico was, I think, one that I remember. Things were changing and frameworks coming up, like in the early 2000s. And then I think something really happened, and this was the starting of Spring. So some people say, hey, Spring and Juice started at the same time. This is not completely true, because Juice was very internal for a long time.
Yeah.
But I mean, the world of dependency injection as we know it today started with Spring. And they had a very interesting idea. They said, we will put all this configuration of all the objects in an XML file. And the usage is code. So we completely separate it and take it out of the code. And this was the whole idea of the thing.
Right.
And with Java 5, we became annotations. There wasn't even annotation support before that. So this is when I think the whole thing really kicked off.
Oh, that's right. The annotation support came Java 1.5. And you're saying the concept of like inversion of control or whatever injection actually predated that.
Yeah. I mean, this is the concept behind dependency injection, is inversion of control, right?
Yeah. Right. And I mean, that was like a common thing, because I remember in my early days of doing like Java web development, and obviously Spring was like the go-to framework at the time. Like the whole Spring Beans and like, I know the inversion of control, that was almost like an interview question, right? Where people would like ask if you even could like wrap your head around that concept.
Yeah, absolutely.
Totally. And it was a concept even not just in the Java world, but right around the same time. I was in .NET in the early 2000s, and we were doing the same thing, IOC, dependency injection. We were just learning how to create service locators, and we were just learning about the first initial dependency injection frameworks that were coming out. So it's amazing that all this stuff was happening, close to 18 years ago.
That's crazy.
I mean, the next thing that happened was Juice. Juice was published. Very similar concept, but they discarded this idea of putting the configuration in XML. I think XML was done by then, and they put it back to the code and brought like dependency injection more how we use it today. I just want to say something really interesting happened by then. So as all these frameworks appeared and everybody had like their own annotations and everything, like as with Java, it always takes some time. And there actually came a specification request called JSR 330, were the whole Java X inject package that we still use nowadays on Dagger and all of those. The add inject annotation, that was standardized back then. This is 8 years ago.
Yeah, that's something. They took the time to think about this, and it's probably lived on for some time, I suppose, right?
Yeah. And then I think right around this time, Android had just been out for a year or two. So, I know a lot of people were starting to look for some dependency injection containers around then. What were they using?
So at some point, I think the first that I'm aware of, but it might be smaller before, was RoboJuice. That was basically the idea. Let's take the idea of juice and bring it to Android, right?
Yeah, I remember seeing. There's a little fun story that I have for RoboJuice. It's actually how I kind of got into Groupon, which we share a common lineage there. So I apologize for any code you had to work on that was mine. It was a little rough back then. But back in the day when I was writing a client application, I needed dependency injection support for the intent service, and it did not exist in RoboJuice. So I created a pull request back in the days of Mercurial for when RoboJuice was on that, and the lead maintainer saw that, and he worked at Groupon, and said, "Hey, I need some help over here." And a little time later, I was there working at Groupon. So. It's some RoboJuice. I was very familiar with it, contributed to it, and so forth, and used it for a long time. So, did you end up using RoboJuice a lot at all, Danny?
No, I avoided it. I looked into some of the smaller ones. There was also a Spring for Android at some point. Yeah. A lot of those. They were all very similar. There was one problem with those. In the end, Google said, don't use them. Actually, they said back then, don't use dependency injection, because all these frameworks had one thing in common. And you probably know about it now, right? They were reflection-based, because that's where Spring and Juice came from. But there's one problem. I mean, we all know this nowadays, reflection is super slow in Android.
Yeah.
And nice side note here, I was once at a conference talking about dependency injection, actually, in Russia. And my co-speaker, Stefan Nicolas, I think he's one of the developers at Groupon. He looked into what's actually slow in reflection Android. And this was very interesting, because that's what I think never really published. So just asking for a field or setting a field is not that slow. It's 3-4 times slower than doing it via normal code. But the moment you're calling a new instance, so this, to create something, this is 100 and more times slower than it normally would be. And this is all a dependency injection framework does, right? It creates a graph full of new instances.
Wow.
And this is why the whole thing was so messed up. We couldn't explain it. It's probably the DEX format or something, but the actual excess of reflection is not that bad. It's this new instance call that messes everything up.
Interesting. So so I understand this right, you're saying basically even in that world, it was the actual instantiation of the object that caused a lot of, the scale of performance hit was far higher because of that? Or is it that objects that you create with reflection, when you call the new on that object that you use through reflection, that's the thing that sort of causes the performance problem? Is that basically what is being said?
So what I want to say is that moment when something like RoboJuice, when they wanted to create a graph, right, and then start instantiating objects. For this object, you need these dependencies, right? So it's instantiate another 3 objects, and then this whole graph starts. And this happens at startup of your application, right, back then.
Right.
And this is so slow, and it took multiple seconds. And I remember the Groupon app was super slow back then. So this was a huge issue.
Oh, got it. Okay. Cool.
And this is why Google in the end had to warn it. Please don't use this, because this messes up your user base in the end, right? User experience.
So where did we go from there? If a lot of folks, I know some folks were using it, you weren't using it, some other folks weren't using it, we were probably looking for a different solution. What was the next thing that kind of came out after that? The one thing that probably everybody remembers is Dagger. So Dagger was a complete different approach. It was done by Square in 2013, I think it was published. And they basically said, hey, this is something similar to Juice. So they took a bit of a different route. And this is the first time that we see the annotation processing as we see it now on Android. So instead of reflection, they generated code and compile time to do this graph creation. And this was a very, very different approach, because it's something that you didn't need in the backend. This was so Android specific. But yes, Square made basically dependency injection for Android possible. Yeah, I remember those days. That's the first time I saw Dagger 1, it was so much faster. And just as we spoke earlier, Kaush, you guys are still rocking some Dagger 1. And I know a lot of companies are still out there using Dagger 1 just because it simply just works and they don't have performance issues with it.
Absolutely. I was working also with it for some time. It was really cool. But there were some problems.
What were the problems? Like, why did people feel the need for the evolution of Dagger 1? Because Dagger 1, like Don just mentioned, has been pretty stable, right? So why the need for something else, I guess, after that?
So from what I remember, there were like two main problems with Dagger 1. One was the code that they generated, right? As I said, like there's code generation behind it. That was super hard to be debugged because it was really awkward code. So if you have to step into this because something is wrong, you had a hard time finding the actual issue. So it was a bit of an ugly code generation there that happened. And there was still some graph composition at runtime there. So the performance wasn't as good as it probably should be. So you still had a trade-off when using Dagger 1 compared to not using any Dagger.
Right. And we've had like Jesse Wilson, a friend of the show before, on, and he's actually like talked to us about how like Dagger 1 worked at the time, right? And how they came up with the idea. And so if folks are curious, like we'll definitely add a link to the show notes there, and like you can go back and like listen to like the explanation there. But yeah, the important point that Danny also brings up is that there is a lot of work that's being done on runtime. So it isn't purely at compile time, which is ideally what we would like, right? So this graph, like part of like the resolution of this graph is done during runtime, which is costly, right? Is that a fair summary, Danny?
Absolutely. And the larger application gets, the more objects you want to inject. So the larger the graph gets. And at some point you have a problem.
Oh, I see. So then the scaling becomes an issue, because once you have like this like huge app that has multiple dependencies, then like that adds to the cost of this graph, I guess.
Exactly.
So is this why we have Dagger 2 around? Did Dagger 2 fix these issues?
That's what I think. No, that's actually what Google said back then. So Google took over the project. I'm not sure how that happened, but Dagger 2 is now driven by Google from the beginning. And they basically took a new approach and they fixed those drawbacks. And now everything is completely compile time verified. If it compiles, it will work.
I see. So with Dagger 2, like now there's zero reflection. There's no reflection whatsoever in Dagger 2.
As far as I know, yes.
Okay.
And then from there, it looks like we kind of stayed the steady course for a couple of years with Dagger 2. And then just recently, Dagger for Android was released. What's the need for Dagger with Android, or the Android extensions for Dagger, Danny?
Yeah, you mentioned it earlier. I never worked with the Android extensions, but I think Dagger 2 has a lot of problems in terms of like boilerplate that Dagger 1 didn't have. And from what I heard so far, Dagger for Android addresses a lot of those. And it brings some extensions also that are very specific to the Android way. Because Dagger and Dagger 2 work on Java, right? They're not Android specific.
Interesting. Okay. I mean, to be quite honest, I've only looked at Dagger for Android when it came out, like the extensions part, but I just didn't bother adding it because, like, I had a tough time dealing with Dagger 2 itself.
Same here.
So I mean, I didn't even like bother to see like the implementation details. But is it just that, was the idea more around, again, taking it to the next level with performance, or is it more just to like build something that would only include the parts that were necessary for Android? Like, do you know? I mean, have you looked into like Dagger for Android?
I haven't looked into it much, so I can't say much about it. From what I heard, it's more like an easier usage and giving you some things that you need on Android anyway. So it's more like more features than like a approach or something.
Okay, that makes sense. Oh, I imagine like some of the activity stuff, right, where you don't have to necessarily or like probably scopes for like activity or something along those lines. So okay, so that makes sense. So it's more about features for Android specifically.
That's how I normally describe it. Yeah.
Okay. So we have, thank you for the fantastic run through of the history of this. I mean, we went really far back into the 90s. That's impressive. I appreciate your depth of knowledge there. But now we got something like Kotlin. And like you said, I'm a developer. I'm creating a brand new application. I have Kotlin. I know I need some type of dependency injection or something similar. Should I be using something like Dagger in your opinion, or is Dagger a good use with Kotlin, or are there any problems that we encounter with Kotlin and Dagger at all?
So that's like a great point, right, Don? Like, I think there's this shared understanding that there's something wrong, like something is not working. At least, like, definitely, I feel that so strongly these days, right? Danny, could you like help us like understand that? Like, what are the problems so far, like that we think about with Dagger, and like maybe like each of us can like talk about it, right?
I'm not sure that you can say it's problems, but as I said, like in the beginning, like I think writing Kotlin code changes a bit your mindset. But there are a lot of libraries, and this is not only Dagger, that are still coming from a Java world, right? And I get more and more the feeling they don't really fit into this new way of I want to program. So, for example, you could question the whole way of annotation processing. I mean, when using annotation in Kotlin, I don't know, it feels wrong to me very often, because annotation processing came from something that Java was missing. But Kotlin brings us a lot of new features. So do we still need annotation processing? I don't want to answer this question, but it's something that we can throw in to think about it. Now, everybody's using annotation processing like all over the place.
So here, I love this point. I really love this point. So here's the thing. I am not that big a fan of annotation processing. I never thought of it this way, but I think like you bring up a very good point, right? Like, so annotation processing was brought in because like Java had some problems with boilerplate, right? And like almost everyone, like the common ding against Java, like if you talk to any other programmer who doesn't have to work with Java anymore, like the most common thing is like, oh, it's super verbose. You have like all these semicolons, there's like so much boilerplate, like, Java is the worst. Like that's commonly like the most, the negative that most people point out. The way that the Java world was sort of saved from this boilerplate was annotations, right? Because that was the thing where like, oh, you just slap this annotation and then you have code that just magically runs in the background, right?
Yeah.
That was the idea. I never thought about this. And it's so funny because when you talk about, this, it feels like there's something wrong with using annotations in Kotlin. That's so right. Because even when you have named annotations and stuff, you know how sometimes you have to like use the @ file and you point, like it just feels like, oh, something's wrong when I'm writing like annotations in Kotlin. I felt it, but I never stopped to think too much about it. And I guess like your point is like, well, in the days of Java, we needed annotations to help with the boilerplate, but we don't need those in Kotlin because Kotlin provides other mechanisms of like avoiding boilerplate, right? Is that the gist of the point?
That is definitely one of them. And also, maybe fun story. I was when I was working at Groupon. One of our iOS developer, he wanted to try Android. I think we were still in the Java world by then, and he said, hey, you guys are not programming. You either write an annotation or you use like the autocomplete from Android Studio. That's all you do all day. And this is like, yeah, there's some truth in that. We are generating everything. But there's another point in annotation processing. I mean, you can think about it, might look ugly, but nowadays it's used everywhere. But annotations, the way we use them, which is annotation processing, so code generation, comes with a price.
Mm-hmm.
So it actually has a build time impact on your builds. And when I worked at Viacom, we at some point, we were a big fan of data binding, and I still am. But data binding brings a lot of build time impact, so slows down your builds. So we actually started removing annotation processors to get back some of the speed. And every single one gave us a few seconds. This was really interesting.
Can you talk about that just a little more? So this is an interesting point, right? Just so folks understand, this is build time, which is very different from like, performance or something. This is when we as developers like actually hit like that command F9 or like, on the build on Android Studio, like this is that time, which in my opinion is like for a developer is like one of the most important sort of impact, like performance sort of driven metrics, right? Like it is so important that as developers we're able to like iterate fast. And you're saying adding more annotation processors or like libraries that do annotation processing impacts that.
Absolutely. It might not be much, but they sum up, right? This is a few seconds, and maybe it was 1 or 2 seconds for this, and then 1 or 2 seconds there. But this is just sum up the time that you're waiting on a daily basis, and then multiply this with the number of your teams. That is a lot of wasted time. And also, I'm a big fan of TDD, test-driven development. So I'm iterating very fast, and I need to compile all the time.
Mm-hmm, agreed.
And here comes the problem of annotation processing. We have a problem, and at least until recently, the way it works with Gradle, it is not incremental. So every time you hit that build, he generates everything from your complete application, or from at least the module that you're working in, because it's not meant to be incremental. Actually, it was experimental in Gradle 4.6, and the latest 4.7 version now has support for incremental annotation processing. That doesn't mean it's there. So I talked to a few library developers. So they now have to start actually using this feature. So there's, I think, a pull request open for Butterknife. I heard that Dagger won't even be 100% there because of the complete validation they need. Auto value still needs another Gradle update. So a lot of things happening, but we are not there, and it will take time. And then comes Kotlin, and we have the APT, the annotation processor, and then we have the Kotlin annotation processor. That's a different story. So
yeah, and that's when like all my faith with annotation processing and like I've become this angry person with annotation processing was after I noticed like how with capped, that is like the Kotlin annotation, like things were broken. My build time suddenly like shot through the roof. It was clear that I wanted to use Kotlin, but because of all the deep and like invasive annotation processing that we have in our Android code bases, I started to feel like, wait, what am I doing this for again? You know?
I think.
Yeah, then you have to ask yourself, is this worth, right? Is those 3 or 4 lines of boilerplate that you're saving, is it worth waiting every day?
Absolutely.
Exactly.
Yeah, and my opinion is absolutely not. Those 3 or 4 lines that you're saving is not worth it. I've in the same camp that you are, Danny, in your previous company, with like some clients that I have now, we're removing a lot of our annotation processing. It could be Butterknife, it could be data binding, it could be some parts of Dagger that we were using before to help us. We have now rewritten so we don't have to incur this build time penalty. And the reason why I'm saying this, again, for the listeners, and Kaushik and Danny, you've both pointed out this, is that you're both fans of TDD. We like to iterate quickly. And if I can't iterate quickly, then I'm going to get distracted by some shiny object. And right now, if I have to build, and for some reason it's going to take multiple minutes every time, and I'm going to build 100 times a day, at least for me, because I'm just always cranking through code, that's going to be minutes upon maybe an hour or more. I'm sitting here waiting for a build to complete. And it's very, very frustrating. It's my biggest gripe right now in Android development. I've been doing a ton of web development on the side, doing some like React and so forth. And the build times on these other platforms are amazing compared to Android. And so completely agree. If you can somehow get rid of that compile time, which is the code generation that's happening behind the scenes, it's going to be a humongous win. But to sum it up, I agree that that's one of our biggest issues with the annotation processor is the build time. And
for context, I mean, I've told this story before. I actually got my company to like change my machine because my build time was improved by about like 6 seconds. So I actually ran this. I took like a 15-inch and I took like the previous computer that I had and I ran like the builds like continuously, and I actually like showed them, hey, I'm getting like a few seconds of like improvement on each build, and like without a doubt, like they just changed my machine because, like Don said, like given how many times you have to do this process, minutes is like crazy. Like minutes is like, what are you doing? Like, why are you talking? Go change your computer right now. Like, if like, you have the means to, but even seconds like can make a huge difference, like in productivity.
Exactly, that's the thing. I mean, we shouldn't just blame annotation processor. I think there are a lot of things wrong often in those builds, right? Like modularization that is missing or something like this. Right. But this is one part of it, and just those few seconds, and like in a large team, this sums up. So at least question if you really need them. As you said, Don, I mean, we remove Butterknife, and there's something better in Kotlin most of the time.
Yeah,
for a lot of those.
So I mean, it's a perfect segue here. Is like, so is Kotlin? Does Kotlin have what we need without all of this overhead that we're incurring elsewhere, or is that what? That kind of seems what your talk was about. What's your whole thought process on that?
I mean, it's a hard question to answer. Definitely Kotlin has features that Java didn't have, right? Mm-hmm. I mean, just think about like lazy and like custom delegates that you can write. It brings us like parts of like functional programming and like all the inlining stuff. So there's certain features that Java didn't have. And we should at least look, and some of the frameworks that are out there that's starting to pop up, they make use of those features. And I think there's worth looking into them. Which parts can we maybe replace? Maybe there's not replacement for Dagger yet, but definitely have a look at those. And that's what I'm trying to do with the talk.
So what exactly, I know there are some solutions out there. What solutions in your talk have you proposed to at least have folks take a look at?
I mean, not a proposal, but so I said I was working with the Screenfield application, right? Mm-hmm. And I started with a library called Toothpick, which is it's a different dependency injection, but it's normal Java-based as Dagger, like the same way, and add inject annotations and everything. And I realized, hey, this somehow looks ugly, and we can talk about what I thought looks ugly. But so I started building some Kotlin extensions to this. This made it already better. But then we start looking, okay, let's look at all these blog posts that are happening right now, right? So I was looking at Koin and Kodine, so 2 of the frameworks that are out there. Mm-hmm. That's not all of them, but these are the 2 that actually we tried out in a POC, and then actually we went with one of them.
Got it. So you had like proof of concepts where you tried with you tried it with Kodine and Koin, and we'll definitely add links to all of these in the show notes. These all start with a K for Kotlin. So,
exactly.
Yeah.
They must start with a K nowadays. So there are like a few things where I think like those frameworks do a better job. And even if you don't use a framework, there are some, I think, features that Kotlin has that those frameworks like Dagger or even Toothpick don't support.
Can you give examples of these?
Sure. So think about like a constructor, right? Normally in Java, you would just do an add inject constructor, right?
Right.
So that's easy, just one annotation. Think about how this looks in Kotlin. The constructor looks really nice, but the moment you have to add inject, you have to explicitly use the constructor keyword and then put the keyword before. And it gets even worse. Imagine you have like default arguments. I mean, it's a Java generated code, so it doesn't see those. So you can't call those constructors. So you start adding a second constructor, which is something we don't do anymore in Kotlin most of the time.
Yeah.
So you're making your code uglier so that the library, it's in the end, it's just a library. The library works. And that's one of the things that I didn't like. Or maybe another example. We got so used to it that I didn't realize before I wrote the talk. When Dagger came out, we stopped protecting our fields that we need to inject. They used to be private final, right, in Java. And Dagger, as it's based on code generation, can support those. So they need to be public. So we're giving up on object-oriented principles. And this is something that struck me. Oh, yeah, actually, those new libraries don't need it anymore. That can be private val. And that's actually a really cool thing. And yeah, we got so used to it that we didn't saw this anymore, I think.
So how are, like, for example, could you walk me through how maybe a field might not have to be public anymore with some of these other libraries? How is that different, or what do they do that's different that allows us to do that?
So the ones that I saw, they all use the idea of a delegate. So don't think about a framework, just think about a lazy, right? So you have a field, let's say view model, you make it private and you say this is of type view model and it's by lazy. And then in that lambda that you're passing in there, you get it from somewhere, right? Your dependency injection framework or whatever. And this is the way they work. You just don't do it manually. You have, for example, a by inject. That is the syntax that Koin is using. So you just declare a field and then say by inject. And it will tell them the moment you're using it, not before, I will get it for you.
Okay, so it is runtime though.
Actually not, because the logic behind it is, it's all inlined. So there's this inline reified logic behind it. So the compiler knows the type and he puts all the code to get you this object there. Which actually not so different from the code generation of Dagger when you think about it in the end, right?
That makes sense. Yeah.
It's just invisible code for you. But I mean, it's there. I mean, you can look behind it lazy or by inject how it's actually working underneath.
You're absolutely right. Like Kotlin's lazy sort of loading it's not actually runtime, but it generates the code and makes it look like that's when it uses it. That makes sense.
So is that's the lazy keyword in Kotlin? And you also said another one, which is I don't even know how to say it. Is it reified or reefed or what? How do you say that word?
Reified?
I think it's called reified, yeah.
Oh, reified. Okay.
Reified.
Yeah, I've been pronouncing it wrong.
Yeah. Can you maybe tell us exactly what that does for someone who's not familiar with it, perhaps, maybe to break it down?
So in Kotlin, reified you can only use for a type when the method you want to use is inlined. That means that the compiler will basically take that method and puts it in a place we're actually calling this function. This is inlining. I mean, this happens in a lot of language. The nice thing with the reified is that you can use a generic, like we do in Java, right? A generic T. And then you define it reified in like one of those inline methods. And as the compiler replaces everything, he knows the type the moment you're using it by your usage. And that means you can actually ask a T for its type, which is something that is impossible in Java, the way like generics work there, right? So, and this is it's a bit weird in the beginning when you look at it, but it's like a really powerful thing to write generics that you can ask for its type. And in the end, this is how these frameworks work. They know, think about like a by inject, they know what type you're trying to use here, so they can write a generic method that actually looks for the right type and gives you the one that you need.
Yeah, the beauty with reified or reified, however you pronounce it, is essentially you get type information, right? Like I think that's so valuable. Like exactly. you get more information about this class, because in the early days with Java, when you had to do this, you would have to pass like the CLASS class sort of type that specifies what this type is, a lot of that can be removed with reified, because essentially now Kotlin allows us to sort of inspect in some ways the information about that class or the type, which is like hugely beneficial, right? Because it opens up this field of like different things that we can do.
So on some of these frameworks you talk about, Kodine, Koin, and so forth, are they very similar, or do they implement, if I want to use some type of dependency injection through the constructor injection, are they very similar, or are they very different? Or if I was wanting to use one, what would that, as an implementer, what would that really look like? And is there a benefit to one or the other?
I mean, it's hard to compare because also the dependency injection frameworks are very different in Java. So the way, for example, you set up a binding in Dagger with the modules or components, it's very different from Toothpick, for example. But in the end, the usage, it's similar. So as I said, like you have an add inject, right, on Dagger, and you have a buy inject, for example, in Koin. So the field declaration is very similar. And then you have a binding where you write a binding. And in the end, they all do something like, hey, if you ask for this type, this is the object, or this is the singleton or the provider that you're using for this, right? So there's different syntax, but it's also, like, I would say, comparable. But you just said there's one big problem, or not problem, drawback that those frameworks have. You don't have this add inject constructor anymore. Mm-hmm. Because there is no one that generates code for you to call a constructor. So you have to go back a bit to, like, if you ever written a dependency injection framework yourself, like it used to be called like poor man's injection. Uh-huh. I think nowadays they have the nice word pure dependency injection. So without a framework, you would, when creating your module or whatever, but you would create all these objects yourself. You would call new blah blah and then new for these arguments, and this is basically what you have to do for them. So there might be much more code you have to write to actually instantiate and create your bindings, because no one generates code for you anymore.
This kind of makes me think of when if I'm wiring things up, or I have to provide them, and maybe I'm using the lazy word to be able to get some type of type or reified or so forth, etc. Some people might say, and I've seen this tossed around a little bit on Twitter through some conversations, that this looks like a service locator. This is not dependency injection. Oh yeah. And this is kind of almost ignited a small war, it seems like, here and there between various folks. What's your thought on this? Is this leaning more towards a service locator, or is this dependency injection, or what's your take on that?
Yeah, and also maybe let's start off, because I know we briefly mentioned what like the service locator pattern initially, like when we were tracing the history. Yeah, what is the service locator pattern, and like what is dependency injection? What's the difference? Like, why all this confusion? Why can't we all just be happy?
Yeah, absolutely. Let's start there, because it can be a very long discussion when you start going down this path. So this is actually one of the reasons why I wanted to give this talk. Was there were all these blog posts happening, but as you just said, they're like people starting to tweet, "Hey, this is a service locator. Oh my God, don't use it!" Right? So because a lot of developers still see service locator, oh, this is this big anti-pattern. I heard it once. Because that's why I went to the history. It started very early. And service locator is it's a pattern that tries to solve the same problem as dependency injection. And then there was this famous blog post in 2004, so quite some time ago, by Martin Fowler, actually explaining all of this. He explained what is an inversion of control container, what is dependency injection, and what is a service locator, and what's actually the difference. So it's a very long blog post, so maybe we can put it later into the documents.
For sure. Absolutely.
In the end, so we all know dependency injection, right? So let's think about, without a framework, you need to instantiate something that needs an argument, like in a constructor. So we need to provide it there. And in the end, someone will put this argument there. I mean, for example, with very easy to explain with the add inject fields that we're using in Android, right? So that's why sometimes dependency injection itself is explained with the Hollywood law. Don't call us, we call you.
Yeah.
So someone will put it there. Don't worry. It will be there when you need it, right?
You know what? I hate that definition because like growing up, because I mean, I grew up in India, and like that's where like I learned like some of my early days in programming. I was like, that makes no sense. I don't even understand what that means. Like, don't call me, I'll call you. Like, it's such a reference, but like, yeah,
yeah, it can be also very confusing. I mean, you can explain a lot of things with that, but for the difference between the two, I think this is really a nice way, because a service locator basically has another actor in the whole thing. So there's one locator, one class or module, whatever, that you actually ask for something. So you can say, so Martin Fowler has this example of a class called Movie Finder. And you would say, Service Locator, give me a movie finder. And then a movie finder needs something else. And we would ask the Service Locator, okay, give me this object. So this is the idea of a Service Locator. So you actively ask for something instead of someone putting it there.
Oh, interesting. Okay, so let me just try to sort of put in words what my understanding is. So the difference with dependency injection is when you need something, it's provided to you directly. But so there are two aspects. With the Service Locator, you first go out asking for this other person who would find the thing that you want for you. So the Service Locator is like this interim additional object that which you may or may not have to write yourself, but basically there exists this Service Locator that you call out to, and that Service Locator would then provide you with the actual dependency that you required for your code to run. Is that right, or no? Am I mixing something up there?
This is the original Martin Fowler discussion. This discussion went on over the last nearly 1.5 decades. The original definition was, this is the basic thing. And interestingly, Martin Fowler back then said, they achieve the same goal. And they just do it a bit differently. But the one problem of a Service Locator that he saw is that every class that needs this has a direct dependency to this locator.
Yep.
And this is a very important thing to keep in mind. And he said, the question is, can you live with that dependency? Because in dependency injection, you don't have this. But actually, Martin Fowler back then said, but even dependency injection, it's much harder to understand. So maybe the Service Locator is the easier way to go very often. So nowadays we think about this as this dark pattern, but actually Martin Fowler didn't saw it like this. But there were actually other developers and people in the community. Don, you said you were in the .NET community. Maybe you know Mark Zeman. He wrote about dependency injection in .NET. Mm-hmm. And he was a few years later reiterating on this topic, because I think this is something that comes back every X years. And now we have it on Android, the Service Locators versus dependency injection. The thing with Mark is that, so this is a few years after the Martin Fowler post. So there were a lot of things said about Service Locator that were just true for a specific library or something, like it's hard to test or something, which is not true. I mean, Dagger is hard for testing, right? So, but it's not. So dependency injection is not hard for testing, right? So, but there were a few things that Mark didn't like. And there's actually, Martin Fowler said, when you look underneath the dependency injection framework, you see a Service Locator. So internally, there will be one big pool where you get the objects out that you need, the dependencies, right? So he said, actually, normally dependency injection is implemented with a Service Locator.
But that was exactly the initial confusion for me. I was like, oh, wait, if I look at the definition for Service Locator, sure, I may not necessarily write that per se, but it has to happen, right? At some point, somebody needs to give this to you, right? There has to be someone who locates these objects for you.
Exactly. And actually, I heard after giving this talk, I get feedback, oh yeah, we are using Dagger, but we're not using the annotations. We're directly asking Dagger, give me the dependencies. So they're using it as a Service Locator directly. So I thought it very interesting. So they're just like the module setup of Dagger.
Oh, you're saying directly calling out from the graph. So if you have this graph that's constructed by Dagger, you're saying, no, just whoop, just point directly to the graph and get the instance that is created.
Exactly.
Okay.
Interesting.
You can use it. I'm not sure if you should, but you can use it like this. So underneath is kind of a Service Locator. But Mark said, that's why we think we should change this definition, because otherwise we only have Service Locators. And he thought so let's not think about the mechanics, let's think about the role something plays. So he said, and let me quote this, so something becomes a Service Locator if it's used incorrectly. So when your application code, as opposed to infrastructure code, queries this service, then you're using a Service Locator.
Mm-hmm. That's
so
exactly
it's your code that asks for something and not some infrastructure code. Because there was actually a funny Reddit post where Jake Wharton says, yeah, you have to admit Dagger is a Service Locator too, right? When you think about it that way, that's why Mark had different definitions of Service Locators, because otherwise everything is a Service Locator.
Right. And this is exactly the quote that I was trying to refer to before. This is the thing that sort of made it easy for me to understand. Now, granted, I don't know necessarily, I haven't been looking at the Service Locator pattern with that much depth, so I may not know it with that much detail. But this is sort of the first statement where it just clicked for me, where I was like, oh, yes, there is always a service locator, but the difference is, do you query it to get it directly? Is the infrastructure taking care of this, or is it like your application code, right? That's the one that's where it like clicked for me. I was like, oh, that makes sense.
Yeah. And this is also where, so Jake was involved in a lot of this discussion on Twitter and on Reddit. And he said basically the same, independent of the underlying thing, there's a big difference that he sees between service locators and something like Dagger, that a service locator doesn't have a public API anymore. Well, Dagger forces you to use this API. And that's also what Mark said, because basically he said a typical service locator has an API called like a generic T create.
Yeah.
So give me something, right? And I mean, this violates everything we know about object orientation, because this is one big method doing it all. And so if you see something like this and use this directly, you're definitely using a service locator.
Oh, can you reiterate that point? Because I think that's like a very important thing. So whenever you see something that says, give me generic T or like give me this object, that almost is like a code smell is what you're saying. That
I would think so. And there's at least the developers who say service locator are bad. Look out for those. Look out for a get or create that is generic and you don't know what it's doing under the hood, right?
Got it. Yeah, that makes sense. And just to reiterate this point, you said the developers who think service locators are bad. Why do they think it's bad again? They think it's bad because of the direct dependency. Can you like explain that point a little? Because again, like I feel that's like there's like some fundamentals there that would be helpful to sort of.
Yeah, absolutely. So yes, there's the direct dependency. This is still valid. This is what Martin Fowler said. But using like an API call, like a create or get, there is no API contract behind this, right? So the problem is with Dagger, you have these nice compile time validation. If it compiles, it will work. If you use a get or create, it will can crash anytime at runtime, because no one can validate if what you're asking for is actually there.
Oh, okay.
So this is the actual problem. So you're putting the problems back to the runtime, and this is why it's such an anti-pattern.
Okay, so I guess like I'm at a point now where I understand why Dagger is beneficial. Actually, going through this like makes me understand pretty well why Dagger has its benefits, right? The APIs you have compile time validation, so assuming something doesn't exist, Dagger is not going to allow me to go through. Okay, that makes sense to me. The second thing that you said is obviously there's no like sort of direct call, or at least like if used correctly, I don't necessarily have to call into this thing directly. Okay, that makes sense. I guess like my point now is, okay, so, but the biggest problem, and this is exactly like what you were pointing to previously, where Martin Fowler said, the biggest problem with dependency injection is like the complexity that's added, right? And I know some people think, oh, it isn't necessarily as complex, but I that is like one point that I very strongly refuse today. Like I will admit I was of the same impression. I think maybe Don and I have like talked about this in like a previous episode, right? Where I was like, oh, Dagger is just one of those things that you learn, but it's so beneficial for testing. It has all these benefits. So just like suck it up, learn it, and like write your app with Dagger, right?
Yeah.
I'm gradually reaching this point where I'm like, no, maybe that was me being a little like, naive, because Dagger is pretty complicated. And like the more and more I see this, especially with folks who come and work on our Android code base from a different platform, they come and see this, like, what is this thing? Like, yeah, sure. Dependency injection as a concept is like simple, but this thing does not look like it's making anything simple, right? Because there is a level of complexity. So that is the biggest problem that we see with Dagger, right? Like, do we like all agree that is like the big problem here?
I mean, I totally agree. This is exactly my point. And it's a bit sad that on Android, when we think about dependency injection, we automatically say Dagger. This is not the same thing. Yeah. One is a concept, one is a library. And there might be a lot of good usage for this library, but a lot of other tasks, it might not be the right tool. But we're always referring to Dagger. And I totally agree. There's so much boilerplate. And what happened is, and I've seen this in my previous company, you would, because no one understands this module and component definition that was once written, so you just copy it over and change it. And if there's something wrong with it, you're copying it, and then like 2 months later, it's all over the code base.
Yep.
I kid you not, I have like this diagram, and I know I've talked about this before, and I promised to like release it, but I will. Every time I come, I have to go back to that. And I was like, wait, anytime I'm creating like a new feature module or something, and I have to write components and modules, I was like, what exactly are these things again? So I have like this like diagram that I've like driven because I've done it more than 2 or 3 times and I'm fed up because I don't want to go back and relearn the whole thing. So I have like this diagram that just tells me, oh yeah, that's how it's all wired up. Okay, so no, really what I need here is like module or a component. So I hear you.
Absolutely. And fun fact, remember when I said in the timeline that when Dagger started, they said, hey, we have something similar to Juice. So this concept of a component, none of the other dependency injection frameworks has. I found it very interesting. They have modules and some of the other things, but I have the feeling Dagger invented their own thing, and it still makes it hard for us, I think.
Yeah, I think that I agree that Dagger does kind of complicate a few things, but you did say something earlier on that I do want to elaborate on, and is that it is important to note the difference between, hey, this is dependency injection, and then there's a library that helps you implement a dependency injection container or whatever. And so that's where Dagger is. It's that library that helps you. You can still do dependency injection completely without Dagger. So just in case if folks are wondering, saying, well, I have to use Dagger because I'm using dependency injection. No, absolutely not. That's not what we're saying. If you want to use dependency injection, you can do it, as Danny said, the poor man's method. Create your own if you want to. It's a hairy road to go down. I don't advise it, but you can do it yourself, or you can use a library such as Dagger or any of these other options, which we have started talking about, which is like Kodine, Koin, etc., to kind of help implement these different patterns for the ultimate goal of separation of concerns and decoupling and so forth.
Exactly. And I think you said a really nice thing that actually dependency injection is not a complex thing. It's a really nice idea. And I liked really, even when I used Dagger 1, I kept it very simple. But I have the feeling over the time we added all this complexity and all our problems we put into this framework. And now this framework does everything for us. And I think made it so complicated.
Yeah.
And a lot of these new libraries, they stick to, 1, 2, 3 classes. They try to narrow down the features that they have, but do those really well. And it's much easier to understand. And if you have a large project or a lot of new developers, that is really beneficial for them.
Yeah, I think one thing that folks need to also do is check their premature optimization at the door. And what I mean by that is a lot of times people say, well, I need to use Dagger because I need all these custom scopes because this shouldn't be in memory here and this shouldn't be in memory there. My first question to them is, have you measured that? Do you know that that's a problem? If you don't, then it's just premature optimization, because a lot of times you'll be surprised that the problem that you think is a problem is not a problem at all.
Oh, 100%.
That's a really good one.
To be fair, though, I think so here's the trouble, right? Like with that idea, I think the folks who talk about that work at really they're in the bleeding edge and they're pushing the envelope for most things in the industry, right? Mm-hmm. Typically the apps they work on are just humongous, gigantic modules where you might actually see a performance benefit. But you know what the truth is? 80% or 90% of all applications that ever will be developed probably won't reach that scale.
Yeah.
And so the problem is what people do is when they look to learn from these people, as they should, they absolutely should, don't necessarily, like Don's saying, step back to think about what your specific goals are. If you're building this MVP that's only going to live for the next 6 months, or you're not even sure if it's going to live for the next 6 months, you know what? It might, and this is more of the startup kind of mentality, right? Which,
very lean.
Just be lean. Maybe it doesn't matter. Maybe it's more important to keep things simple and have 2 or 3 people be able to effectively contribute, right? And I think this is, and I don't know, and I'd be curious to hear your thoughts on both of this, right? But I think eventually it's reached a point in my career where I was I know when I have to make the better decision to scale something or change something, it's going to be painful one way or the other. Very rarely have I reached a point, and maybe this is an indication of the way I develop, right? This whole startup mentality thing. But I found myself that always when I have to scale or make something grow, it is painful regardless. Very rarely have I been in a position where I was oh, because I took this decision to do this thing, it just automatically scales very beautifully. You're going to hit that wall one way or the other. So why not just try to make your life easy for now? I guess it's a trade-off though, right? How do you do that responsibly in a way where you at least allow yourself to be able to scale, even if it's painful? So I don't know.
Yeah, I think but it's important thing. And in the end, you should see something whatever dependency injection framework you're using, right? Try to keep it simple. Try to keep it separate. For example, Uncle Bob would say in his clean architecture posts, dependency injection, for example, only belongs in the outer layer. It has nothing to do in the rest of the application. Yep. So try to minimize the way you use it. And then it's actually easy to replace. I think when I was at Groupon, we were in the merchant app, and we replaced Dagger 1 to Toothpick in 2 days. The complete dependency injection framework, and everything was working fine. And I've been there multiple times, just change one library to the other, and this is how it's supposed to be. Sometimes it's harder, sometimes not, but it shouldn't be a big thing. And don't build like your architecture around the library. If it's Java, if it's Dagger, whatever, right? It's just another library that helps you achieving a goal. That's how I see it.
That brings up a good question, and maybe you have I'm wondering if you have a rule of thumb or heuristic that you follow. As a developer, and I'm using Kotlin or so forth, should I be using Dagger or should I be using Kodine or Koin? Is there anything that kind of falls into like these buckets as here's where maybe you should look? Do you have any guidance for folks that are looking for some help?
I mean, I'm not an expert here. I was doing a POC with 2 of them. I was actually using one of them. So we went with Koin. But the answer here is it depends. But there are some actually a guidance I can give you. If you have a mixed project of Java and Kotlin, you cannot use one of those new libraries.
Mm-hmm.
Because something like this inline reified will only work with Kotlin. So at least that part needs to be completely Kotlin. So in a mixed project, maybe you have to go with one of the Java libraries. Then you should really look into what features of a dependency injection framework or service locator, whatever we define as, right, do you use and do you need? So I realized, for example, that scoping in Koin is a bit different than I was used to. And this was a surprise because I thought, okay, it supports scope, right? So that's why you need that POC to really figure out, is things working? I had someone coming to my talk and he said, yeah, we tried to migrate to Koin, but now I'm injecting a set of interfaces here. And I didn't even know that it was working in Dagger, which is pretty cool. You get like all the implementations. And this is something that, of course, with this inline reified logic will not work. So there are a lot of things that might not work, especially something like Koin. It is meant to be super simple. So check if everything that you need is actually in there.
That's a fantastic answer. I really like how you answered that, starting off with, kind of the depends and then hopping into, hey, if you have Java in your project, this is something you're going to want to consider, et cetera. That's fantastic because I think that's probably the exact way that I'd answer it as well, because you need to think about your exact situation and it's not going to match the one that I have, or the one Kaushik has, or the developer that you may follow online that works at a startup that has a humongous growth that most of us don't ever encounter. So fantastic choice in the answer.
So I guess in the early days when we talked about why everyone should be using Dagger. Obviously, one of the big reasons, and this is also one of the selling points that I have when I introduce Dagger into an Android app, right? Is because it enables testing, especially the early days with the UI testing in Espresso. It actually did allow that in a way where you could sort of supply and mock these modules and then provide them in an effective way, right? So being able to do proper testing is super important, and Dagger did allow that, right? Danny, what are your thoughts around testing for some of these sort of newer libraries, right? Do they also provide the same benefits? Is it easier? Is it not possible? Is there a problem? What about service locators? Is testing inherently difficult with service locators? Can you walk us through some of those ideas?
Let me reiterate what you just said. So one of the reasons you started using Dagger was the testing part. And actually, this is the one point where Dagger 2 is also really bad.
Great.
Actually, the documentation said, sorry, don't use Dagger in tests.
Yeah, it's true.
Oh, wow, really? I didn't know that. Okay. Uh-huh.
Yeah, you can't override actually bindings in Dagger as far as I know. And this is a big problem, especially in unit tests, if you want to test something like activity or fragment where something gets injected. So some of the other frameworks, and doesn't have to be the Kotlin one, are actually better in testing there. I'm very happy with what Koin offers me for testing. So it is super easy. You just define a binding again, and it will override the existing one. So I can use my actual graph and just replace 2 with a mock, for example. So that is really, really helpful for testing. And for me, this is one of the most important parts. But this is, again, something you have to answer by library. That, a service locator is not bad or good in testing, right? It is if the library allows you to. A dependency injection is good for testing if it's allowed to override something or to replace something. Mm-hmm. And so I think you have to try it out. I know that Koin is really nice in testing. And you can even inject the real thing from your graph also in your test, which is also nice. And then you can just verify without having to open a field or something and check if something actually happened.
For folks that are wondering too, if you're using Dagger 2 and you're thinking, oh, great, now I can't test, that's it's just much more difficult to test. You have to use test components and stuff like that. There's blog posts, and I cover it in Macaster.io course and stuff like that. But it is possible. It's just not as easy as it was in Dagger 1, not at all.
Yeah, and I think it's like to what Danny was saying, right? Like there's a limitation that's enforced about overriding the bindings, which makes it difficult. It doesn't make it impossible. It just makes it very difficult.
Testing is like a good point. So when you go to one of those service locators, and actually, I mean, you should only see them as service locators when you use like field injection, right? If you use like everything to the constructor, I mean, you don't notice a difference, right? It's just like the initial class who creates it and how do you get it from. But in the end, when you use one of them, you lose a bit of the compile time validation of Dagger, right? But I'm a TDD guy. Every line of code I write, I have a test for it anyway. So there is a validation. And for example, Koin brings a nice feature that they call it dry run. There's one method that you can call in the framework and will validate your whole graph if everything that's needed is there.
Really?
Some of the validation you move from compile time, yes, to runtime, but it's your test runtime, which is still very fast, I think.
Oh, so out of curiosity, do you have like this one test that you just run and you run like the graph validation, and if that fails, then like, okay, something went wrong? So it's...
Yeah, this basically means you forget to add like a dependency in your binding. And then I just spawn up the activity of Fragment and see if they work, right? If like all the injection actually happened. So you have one test each, and then you're actually fine without needing all the compile time validation.
Oh, that's an interesting aspect. Like where you're trying to cover your base here with testing instead of like necessarily like, so you still make sure that you don't release something to production and then realize the problem in runtime. But the way you're doing it is like through adding tests, I suppose, versus like having that in compile time.
I'm following there like a bit like Uncle Bob and all of the things that he wrote about testing. When Kotlin and Swift came out, he was a bit against it. Maybe you've read that blog. He basically said, hey, whose job is this to manage now, the language or the programmer? I mean, we as programmers do these defects, right? So, and the way to validate from his point of view is not using the compiler, but it's using a test. And I like that.
Danny, this has been amazing. Thank you so much. I think what we should do now is like, because this itself is like an amazing like concept, and like I know we can go on for like way longer like discussing this, but when you said that after this conversation started to like crop up, you went back to like the basics and you started to like try to understand some of these fundamentals, right? Could you point our listeners also to some of these resources that you think would be helpful, like in case people are like more curious about this? What would be some good places to go back and sort of like learn these concepts?
If you want to understand and reiterate on like the service locator dependency injection, read the Martin Fowler blog on martinfowler.com. Read the blogs from Mark Seaman. They're easy to find.
Perfect.
And other than that, I would say there are a lot of articles out there just how to start with Koin and Kodine. Play around with it, maybe in your personal pet project. Mm-hmm. Don't just start to migrate because there's a new library, because it will be a very painful process probably if you're a large application. And there's probably no reason why you should, right? So it's all about the needs. But yeah, look into them, and they offer some really cool features.
Perfect. Thank you so much. And if folks want to reach out to you, maybe if they have follow-up questions, or they were like, hey, you mentioned this thing in the episode, can you like expand a little on this? What would be a good place to reach out?
It's always good to reach out on Twitter, at Preussler Berlin. They reach me, and yeah, we have a lot of discussions about dependency injection there too.
Fantastic. We will do that. Don, I hear you're converting all of your Dagger 2 back to Dagger 1, and then you're removing Dagger 1 and then changing all of those to constructors. So where would folks, for this wonderful process, where would folks reach out to you?
So folks can follow me on that joyous journey. They can reach me at Don Felker on Twitter, and the same thing on Instagram. But Kaushik, I think the real interest here lies in how you're removing RX and going back to async task. And how can folks figure out and watch you in that journey?
Kaushik Gopal on Twitter is where I have that riveting storyline. So that would be a good place. And on Instagram as well, if you want to take a break from the coding. So thank you all so much for listening. Danny, this has been amazing. Thank you so much for helping and walking us through this. We had a lot of fun talking about this. Thank you so much.
Thank you, Danny.
It was fun. Thanks.
Thanks for listening, folks. We will catch you in the next episode.
Once again, we'd like to thank our sponsor for today's episode. That's bitrise.io. If you're looking for a continuous integration and delivery platform, look no further than bitrise.io. With built-in configuration detection, build, test, and deploy in minutes, tons of different integrations, great CLI tools, and much more. Check it out at bitrise.io.
That's it for the show, folks. Fragmented is hosted by Don Felker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.